When it comes to graphing, most of the time, I'm going to recommend that we just use a Desmos or a handheld graphing calculator. However, getting a sense, making a rough sketch by hand isn't that hard, and I would like you to be able to do it. So here's the process. When you are graphing an exponential equation, we know it's going to have either that growth shape or that decay shape. So all we really need are a few points to draw our growth or decay curves through. I recommend always using the y-intercept because remember, that's easy to find. So on our graph, the y-intercept is at y equals 4. Then choose a few other x values. I do recommend at least one on the positive side, at least one on the negative side, and plot those points so you have a guide for the places to draw through. Let's do it this way. How about making a table? Some x's, some y's. We're going to use the y-intercept. That occurs when x is 0, and we know when that happens, y is 4. So there's 1 point already. Then let's choose an exponent that's negative. How about something like a -1 or a -2? Let's maybe even do them both this time. And on the other side, why don't we go with at least a 1? Yeah, that may be enough this time. Now, I chose to do an extra negative point just because I can tell by looking at these numbers that the results are going to come out nicely. If you don't know that, just try it anyway. Do a little guess and check. Nothing wrong there. All right, let's do the easier one first. That's going to be this y coordinate here. So for this one, I want to evaluate 4 times 2 to the first power. So think it through with me. 2 to the first power, that's just 2. And 2 times 4 would take us to 8. So there we go. That's an ordered pair I can plot, 1, 8. In the other direction, when I put in a negative exponent, 4 times 2 to the negative first power, remember what a negative exponent does. Flips that 2 upside down, makes it into a 1/2 to the first power. So the negative flips, the 1 stays behind. Well, a half to the first power, that's just a half, and half of 4 is 2. How about 4 times 2 to the negative second? That's the same as 4 times 1/2 to the positive second. So the negative exponent flips the 2 upside down. A half to the second is a half times a half, which is a fourth. And then a fourth times 4, that's just 1. And look at this. Now I've got 1, 2, 3, 4 different ordered pairs I can plot to get a sense of what this graph should look like. Now, I didn't put numbers on this grid yet because as we've seen with exponentials, sometimes the numbers get really big really fast. So I wanted to be able to make my own scale. So I'm going to set it up here. This is 1 and 2. How about -1 and -2? And now vertically, I've got to go up at least as high as 8 so that I can get this point plotted there. So I'm going to count 1, 2, 3, 4, 5, and then 6, 7, 8, 9, something like that. Let's plot our points. So -2, 1 would be about there. -1, 2 would be about there. 0, 4 would be about there. And then 1, 8 would be all the way up here. So I'm seeing this exponential growth happening. And now just kind of do your best to make a sketch that goes through your points. And off you go. Something like this. Arrows on the end, arrow on the end. Make sure that as you are going backward here, in this case, since it's growth, that it does show you're going flat. Remember, you don't ever cross down into the negative y's, so you've got to level off with that horizontal asymptote at y equals 0. And there it is. This is not different than how you plotted lines. You find some ordered pairs, you put those ordered pairs on a graph, you graph between them. Same thing here, except now it's something curvy. Okay, just for practice, I would like you to give this a shot on a paper or on a marker board, whichever you prefer. you can do a pause, or I'll show my work here, but I won't talk so much, so it'll maybe be a little quiet for you. I will just say, you don't have to do these by hand. Matter of fact, the calculator is there for this exact reason. But you should end up with, if you chose these as your x's, you should end up with those as your y's. I won't always choose -1, 0, and 1 as the x's, but I will most of the time, because those tend to be the easiest ones to work with. So once again, just setting up a scale. Plot our points. So -1, 8, 0, 4, 1, 2. All right, so it's a decay pattern this time. Now, even without listing another number in the table, I'm spotting that each time my exponent goes up by 1, so up by 1, up by 1, my result gets half as small. That lets me know that my next ordered pair should be at a height of 1. That extra point makes it a little easier to draw a good curve. Now you'll notice I'm just trying to kind of sketch things through here. I didn't hit all my points perfectly. That's because I'm not an artiste, but you get the gist, right? We see this sort of exponential decay pattern coming through on this one because this number was between 0 and 1. And if b, the number with the x as the exponent, is between 0 and 1, then you get a decay pattern. Okay, let's do one more for practice and for fun. Same deal. Why don't you do yours on your marker board or on your paper, and then we will check in just a little bit. So that's real tiny. And I think, as I'm looking at these numbers, those are all pretty small. I'm going to add one more here, just because another point might make it a little easier for me to make sure I'm getting the right overall general shape. So I'm going to do a 2 as well. It's a little bigger. 1, 2, 5. Okay, so my x's and my y's. So goes down real low. I got to make sure I go up as high at least as 6.25. Right. And now because these are decimals, we're going to be estimating, but really we've been estimating the whole time anyway. So at -1, 0.05, it's just real low. So I'm just putting an ordered pair or a point here, real low, not quite on the axis yet, but very low. 0 and a fourth, well, that also should be real low. 1 and 1.25, so something like this maybe. And then 2 and 6.25. Look how fast this goes up. 5, it turns out, is actually a pretty big base. It's going to give you growth, but it's going to give you fast growth. So something like that. Oof. And in the other direction, it's going to go flat real quick. So real low, real flat, and then it's just going to kind of stay that way. That's that exponential growth pattern with that big base of 5. Now, just so you know, I'm glad that we've seen this. I would expect you to be able to do this. But when it comes to your practice and your power assignment, if you're supposed to make a graph, you'll have access to your Desmos, and it'll also probably be sort of a multiple choice question, just to put your mind at ease a little bit.